Now let's move on to joints and what we can do with them. So we had discussed these yellow and blue joints before. The yellow ones were end nodes and the blue ones were intermediate nodes. What you can do with them is you can select any one of them, double click on it, and it will give you this option of adding a restraint to that particular joint. And you can obviously have U1, U2, U3, R1, R2, R3. Those are the restraints you can have. If you press this one, then the whole thing gets fixed. Press this one, it's a hinge. This can be a roller. You can modify them manually as well. But what else can you do with joints? You can select any joint and you go over here and you can assign a joint mass to that joint. And the joint mass, you can give it a name. You can give it translational masses in the 1, 2, and 3 directions. And you can give it a mass moment of inertia about the node in the local axis 1, 2, 3. And you can define the units over here. That's one thing you can do with joints. Another thing you can do is you can assign joint springs. So if you want to model the soil and you don't want to make it fixed, but you want to model it like a spring, then you can assign a joint spring. Similarly, you can assign joint restraint, which is what we just talked about. And you can also assign multi-joint constraints. Now, what we mean by that is if you select more than, let's go to the site, for example, if I were to select an entire floor and select the joints on that floor, and if I went into the assign multi-joint constraints, I have the option of assigning, making it a rigid diaphragm, or giving all the selected joints an equal constraint, or giving the selected joints a rigid body constraint. In the case of a diaphragm, you can give that diaphragm a name. You can define the constraining axis, which is usually Z for the horizontal floors, but you can even make it along any plane. By selecting the auto option, whatever plane is defined by those joints, it will be taken to be perpendicular to that plane. With the equal constraint, then you have the option of defining which particular degrees of freedom will be equated as far as those joints are concerned. You can give it a name once again. You can save them away. And for the rigid body one, you only need to give a name. There's nothing you need to define because the bodies the selected joints will behave like a rigid body. There's a difference obviously between a rigid body constraint and a rigid diaphragm. The rigid diaphragm doesn't behave like a rigid body. It behaves like a rigid body only inside the plane, not outside the plane. Now, since we talked about assigning masses to joints, let me just remind you that you don't always have to do that. When we go back to the load cases, and in the load cases, you can specify any particular loads in a load case to be converted to mass during the analysis stage if you're doing a dynamic analysis. And you can say that any load which I enter under this load case, you convert it to mass with a mass conversion ratio of whatever this number will be. Now, codes will usually specify these numbers, and 0.3 is a very typical number for live loads. And the reason they have that is because the live loads are usually modeled as frame loads, but in reality they exist as masses as well. But the participation is not 100% because of various reasons. And what the code specifies is that you should actually consider the mass when you're solving for the dynamic properties of the structure. You should consider the masses of these live loads or equipment loads or basically any load which is there physically as well. So you have the option of converting these live loads or other loads into masses from the load cases as well. So when will you actually assign a mass to a joint directly is when you will not have the equivalent load for that, or you haven't converted that load into a mass. Now, what it will do is if you tell the program to convert it into mass, if it's a joint load, it will be directly applied as a mass to that joint. But if it's a frame load, then the load on that frame will be divided into two parts, and one part will be assigned as a mass to the left node, and the other half will be assigned to the right node.